Hello, everybody, and welcome to the August Virtual Planetarium with Pete Lawrence and me, Paul Abel. And as ever, we will start with the inner solar system and move outwards. I have a feeling the solar system isn't going to take us very long this time. But let's start with Mercury. So Mercury reaches inferior conjunction on the 1st of August. So effectively, it's between us and the sun. And as a consequence, it will be rather difficult to see till about 19th of March when it emerges from the sun's glare in the morning sky. But it is going to be a bit of a tricky one, isn't it?
Yes, it will. On the 19th, it rises a little under 2 hours before the sun does. And on that date, it's shining at about mag plus zero point 0.1, which isn't the brightest that Mercury ever gets. But it will be located 2.5 degrees south of the Beehive cluster, although at this time of year, the morning twilight does tend to make these sort of views a little trickier than normal, shall we say.
Yeah, it's not an easy one, is it?
Now, there's a nice 4% lit waning crescent moon joining the scene, actually, on the 21st of August, and that will be located 7.6 degrees to the northwest of a slightly brighter Mercury at mag minus zero point 0.2. But it's going to be a tricky one, really.
It is. Moving out, planet Venus is very much still in the morning sky. I had a look at it fairly recently. It's now past dichotomy. I'm going to give a thanks to Pete Lawrence for coming and collimating my telescope, because even though I've owned it for many years, I've still struggled to collimate it properly. Oh, it's a right faff, though, isn't it? Getting the mirror collimation right. So it's
on a big scope. It can be quite tricky. You need a couple of pairs of hands really to do it. But
I've got a good view of Venus with it, so I'm quite pleased. It's got a close encounter, actually, a very close encounter with magnitude minus 1.8 Jupiter on the 12th of August, and both planets will be just 52 arc minutes apart. So that'll be quite nice.
That's really close.
It is.
Yeah, that's really good. Yeah. And of course, if you watch those planets at the beginning of August, all the way through the month, really, you'll see them gradually get closer and closer to one another, pass one another, and then zip off as they split up again. The conjunction on the 12th is quite a nice thing. As you say, 52 arc minutes, you could fit 2 full moons, more or less, in between those 2 planets at that point. And that is an event which is known as a conjunction. We tend to use the term conjunction to talk about when 2 or more objects are very close together in the sky. But of course, there is actually a technical definition of conjunction. It's when the 2 objects share one set of celestial coordinates. So, for example, if you've got 2 objects which have the same right ascension, that is technically a conjunction in right ascension, or it could be galactic longitude or ecliptic longitude. So there is actually a definition for conjunction, but we tend to use the casual definition where it's just 2 things close together in the sky.
But it is nice that it has a proper definition. And of course, the Beehive cluster, although normally very prominent, of course, in the winter when it's in a dark sky, is actually a very tricky object in a twilight sky.
Yes, it is. It is, because the stars just don't have enough brightness to shine through, really. Which is a bit like Mars, because Mars isn't very well placed at the moment. It's located above the western horizon after sunset, but it's compromised by the bright evening twilight. Not particularly bright planet.
No.
The twilight engulfs it.
It does. Mars is doing its hanging around bit, isn't it? Just it'll do this for many months before finally it reaches conjunction and then emerges on the other side.
The hanging around phase.
The hanging around phase. Is that another one of your technical details?
Well, there is a technical definition for hanging around. No, there isn't.
No, it's just we call it the Martian loitering phase. That's what we'll call it.
MLP.
The MLP. Well, as we've just seen, Jupiter's in the morning sky. It doesn't quite reach optimal position before sunrise, but it is moving rapidly in the right direction. Shines at magnitude minus 1.8, so very, very obvious. And on the 20th of August, both Jupiter and Venus will be joined by a 10% lit waning crescent moon. So it should form a distinctive morning planetary lunar triangle, I would say.
Yeah, I mean, Jupiter is going to be really good towards the end of the year. It doesn't actually reach opposition in 2025 because...
No, it doesn't.
No, the period between oppositions is just over a year, and the last one, I think it was 7th of December, wasn't it, in 2024? Yeah. So it's just enough to push the planet's next opposition into 2026. But that doesn't mean you're not going to get a good view of Jupiter. It's going to be fantastic this year, really fantastic, because it's going to get really high above the horizon. So this is the year to hone your planetary skills. We've been moaning for years that the southern hemispheres had the advantage with all the planets really low down, so it's high in their sky. But now the planets are high in our sky, so we've got to make the best use of it.
Absolutely. And Jupiter, doesn't matter what size telescope you have, you will always see something on it. And it's a constantly ever-changing world. So plenty for us to do. Okay, well, the next planet out is Saturn. And if you put a telescope on it, it's in the morning sky. You won't see much of the rings at the moment because the planet's only slightly tilted towards us.
Yes.
So they're not going to be in their full majestic view. So things like the Cassini division and the inner dark C ring are probably going to be very, very tricky, even with a large telescope. But still worth looking at because we don't very often get this kind of view of Saturn.
No, and it actually is going to get more exciting because as we go through towards the end of the year, the rings are actually going to tilt to a shallower angle. So sort of from mid-November through to mid-December, they're going to be about 0.4 degrees, the tilt, which means that for a small telescope, I think they will virtually disappear at that angle. If they are there, they're just going to be the thinnest of lines. But what's exciting about it is the fact that when we had the ring plane crossing earlier this year, Saturn was really close to equinox, so the shadow of the rings onto the planet's globe was really thin. But as we go through to the end of this year, Saturn is away from equinox, so the sun's angle is able to cast a shadow of the rings onto the globe, which is quite well defined.
It is. In actual fact, and we should perhaps just explain to viewers, before Saturn, if you're looking at Saturn through a telescope with north at the bottom and south at the top, before opposition, the shadow of the rings of the globe are above the ring system. They vanish at about opposition, and then afterwards, the shadow reappears, but below the ring system. And if you look early on before opposition, there's a definite curvature to the shadow of the rings on the planet. I've seen it with an 8-inch telescope. It's quite distinctive.
But that's something to look forward to with Saturn, because it is going to get better now, isn't it?
It is. And of course, satellite transits as well. We get them all the time with Jupiter, but having them with Saturn is much more rare.
Yes, but the Titan interactions, I've been going on about them for ages, and in the magazine I'm sure people are fed up with hearing about them now. But the thing is that they will, the shadow transits, or Titan's shadow transits, will end fairly soonish because of the angle of the sun relative to the planet. So you haven't got many opportunities now to see this, and if you miss them now, it'll be another 13 years or so before they start up again, which is always a bit disappointing.
It is, yeah. It's a long way away, actually, yeah.
But we do have a number of Titan transits, which I've never actually recorded a Titan transit, so I'm quite excited about that.
I have never seen one either. No.
I mean, there were some earlier in the year. There were transits of the shadow earlier in the year, not Titan transits. They weren't very well timed, but the shadow transits, I remember going out on one night when it was clear, thinking, I've got it now, and the seeing was so bad that you could barely see the shadow.
That's kind of thing. That's the problem sometimes with observing planets in the winter, is if the jet streams nearby, just destroys the seeing completely. But anyway, let us hope for the best for these upcoming satellite events.
Yes.
Further out, the planet Uranus, well, actually, it's surprising how rapidly darkness expands throughout August, and it's perfectly timed for the planet Uranus because that's starting to reach a decent altitude above the southeastern horizon before the onset of dawn towards the end of August. So now's a good time to find it. Even the small telescope will show you this tiny little greenish disk. But if you look with 8-inch telescope or larger, the pole of the planet is kind of pointing towards us now, and it is noticeably brighter than the rest of it.
Right, that's interesting. Okay, well, I think Uranus is actually in a good position at the moment because it's to the south of the Pleiades. So unlike previous years where it was a little harder to locate, Now it's going to be pretty easy to locate. And it does give an opportunity, because I think as we go into next month and beyond, it's a little brighter. It's about mag plus 5.6, which is right on the threshold of naked eye visibility. But if you've got a dark sight, because it's near the Pleiades, it shouldn't be too difficult to track the planet down. One of the big problems trying to see Uranus with the naked eye is that there always seem to be stars nearby which are of similar brightness. So you think, yes, I've got it, and then you think,
I've never been able to convince myself, Pete, that I've actually seen it with the naked eye. As you say, there's just too much stuff around, and at that low level of light, there's also what looks like, sort of the granularity of the sky. It's very difficult to be able to see, to say you've seen it. So I think early astronomers can be forgiven for overlooking it.
Yeah. Well, I think we have a good go this time round to see whether we can actually pick it up with the naked eye. I think that would be good. Okay, let's go to the final planet then, which is Neptune. And Neptune is very close to Saturn at the moment. They're a pair in the night sky, if you like. Like Saturn, Neptune is going to be able to reach maximum altitude under true darkness from about the middle of the month onwards. So it's a good time to get with Neptune as well, because Saturn is a good guide to locating this dim world. But it's a tricky one, isn't it? A tricky one to see much detail on.
Yeah, I've never really seen any detail on it. I've pointed some very big telescopes at it, and it just looks like a bluish disc.
A bluish disc. But you can see its biggest moon, Triton.
Yes, you can. You can do that. That's visually, that's all you're going to see. Okay, well, we've got some nice specials this month. So on the 2nd of August, in the evening, take a look at the crater Plato, where the shadow is formed on the floor from a rim peak. The shadow has been described as appearing curved in the past. This is something Pete and myself have talked about a few times, as Clara Obscura effect, known as Plato's hook. I've seen Patrick's notebook with the drawing in of Plato's hook looking curved, but I've never seen it myself, I should say.
That's the first reference to it being curved, isn't it?
I don't think I've ever seen it referred to anywhere else in the literature.
No.
But here, Percy Wilkins did say that that's what it looked like. But have you ever seen it? Have you ever imaged it?
Well, it's an interesting one because whenever I've seen it, it's the gamma peak which casts a shadow across Plato's floor at dawn, when the dawn light hits the eastern wall of Plato, and it casts this shadow onto the floor, and you get this gamma peak. It's like a shark's tooth sticking up. But I think it's always a little bit too developed. I think you've got to catch it when it's quite close to the rim, and then you have a chance of seeing some curvature, because there is a sort of scree field there on the inside of the rim. I mean, Plato is I always describe it as being like a swimming pool. It's got this rim and then a really flat floor, but there is debris in the southeast corner, and I think there's a chance that the shadow may go across that and give a curvature, or have an appearance of being curved because of that.
Yeah, if that's so, then that's probably going to be very, very sensitive to the libration changes. So
yes,
it's
absolutely.
It's no wonder that the effect isn't seen that often at all.
Well, you'd think it would be easy to see it because you can predict when it's going to occur, but of course the moon's got to be above the horizon, it's got to be clear, and the shadow or the phase has got to be exactly right. So it's not actually that easy to get the timing right on it.
No, and on top of that, we don't know if the effect is visible in small telescopes. Patrick and Percy Wilkins were using the big 30-inch refractor in Paris, so it's entirely possible that it was an effect of circumstances using a very large aperture. Don't know, but it is certainly something I look out for every time I look at Plato, and it's kind of the moon is in that kind of phase.
It's good to have a little sort of puzzle.
It is.
To continue to try and solve. There's another Clair Obscura, actually, which is visible on the 5th, on the evening of the 5th, and that's when sunlight hits Mons Herodotus, which is quite close to Aristarchus, and that creates a Clair Obscura effect known as the star-tip mountain. It looks like a little star.
I have seen that. I saw it by accident, and I thought, what on earth's that? And then that's when I looked it up and thought it was this fairly famous clair obscura. It's quite striking if you're not expecting it, and it just switches on. You do wonder what's happening. It is quite a silly.
I thought you were going to say, I saw that, and I looked at it, and I looked it up, and I realised it was the moon.
No, Pete, no. I knew it was a lunar feature. I'm not that bad. But bless you for your much needed commentary at this time. But sticking with the moon and not Pete's nonsense, we shall catch the full moon rising about 21:30 on the 8th. It's 21:30 BST, I should say, on the 8th of August. And this is a good time to experience the moon illusion. This actually is the very best time. The number of times I have really been caught by the moon illusion in August, July and August, when it's really low down and it looks enormous. Of course, it's no bigger than at any other time, but it is very striking, particularly if you see it through a car window or something. It really is striking.
It's funny you should say that. I've always seen it when I've been driving and never had sort of any means to stop, and you sort of see it appear above a road and then it's disappearing behind trees and houses, and you think, oh, I'll just drive up here a bit further and I can see it, and there's always something in the way. But it is an interesting effect. I mean, I've seen it when the moon has looked absolutely massive, and I've convinced myself that it has moved a lot closer to us. It must be to get that big, but it isn't any bigger. But the other morning I caught the full moon rising, and it was late in the evening, but it was an awkward hour, and it was just creeping above some horizon silhouettes, and as it appeared, it didn't look huge at all. So there's obviously some weird effect.
I think it must be a combination of psychological factors. I think somehow, I don't know why, but in the evening sky, it tends to be nearer buildings, and there's something about the colour. The colour of the evening sky is actually quite different to the colour of the morning sky.
Yes, it is.
And I think all of these factors come to bear. I don't think there's any one particular answer to the moon illusion. I think it's all this. Because like you, I've seen a full moon low down in the morning, and it isn't as striking somehow as when it's in the evening.
It's a very interesting effect. I do like it, and I enjoy it when I see it. But it, it's like washing a kettle and waiting for it to boil. If you actually watch for it, you don't see it. It's only when it catches you unawares, I think, that you really sort of get the full impact of it.
Yeah.
Anyway, let's head away from the moon. And on the 10th of August, minor planet 2 Pallas reaches opposition, shining away at mag plus 9.4, so that small telescope territory, against the stars of Delphinus, the dolphin.
Which is a lovely little constellation. And on the 12th, of course, we have the Perseid meteor shower reaching its peak. But alas, it's completely destroyed by an 84% lit waning gibbous moon that's really going to interfere. But that's no reason to not go out and have a try.
You can still see bright meteors. What you've got to bear in mind is that, I mean, the zenithal hourly rate equation is very sensitive to the clarity of the sky. And if you have anything which affects the limiting magnitude, i.e. a really bright moon, it reduces the number of meteors you're going to see dramatically. So you're going to drop from a ZHR of about 150 for the Perseids down to a visual hourly rate, probably 1, 2, maybe 3 meteors an hour.
Yeah.
And that takes a bit of patience to actually sit outside and observe that.
But at least it's warm. You can sit outside with a barbecue and just wait for it to happen. Although barbecue's probably not a good idea, to generate loads of smoke and heat. I have to say, I haven't had a good Perseid meteor shower watch now for ages. Although you, of course, have now got your meteor cams set up, so you'll be able to follow them and carry on following them all now, even if you're not going to go out and actually observe them.
I can lay in bed and watch the shower.
Be very, very slow entertainment, I should think.
I do remember actually doing years ago, I mean, this was probably in the early 90s, working with some video setups to record meteor showers. And it was rather wonderful. Nowadays, of course, you've got programs which can detect meteor trails in an image. But back in those days, you used to record them with sensitive cameras onto videotape. And the only way to get the data off was then to go through the videotape and watch it all over again.
Right.
So all you did was defer the watch to a more convenient time of day, which I always thought was quite amusing.
Yeah, the hours literally must have flown by. Oh dear. Okay, so yes, do watch out for the Perseids. I believe you have advice on how to photograph the Perseids in moonlight in the August Sky at Night issue.
Yes.
Also, we have another cloud obscura on the 16th. If you locate the last quarter moon in daylight in the morning sky around 10:30 BST, so 9:30 UT, you can look for the bright line made by the straight rule rupees rector. And this illumination forms sort of like a blade-type clair obscura effect known as the cutlass.
Yeah, it's interesting. It's the opposite of the one you get earlier in the phase cycle where the straight wall looks dark. This one looks bright because the slope is being illuminated. So it does look like a proper blade.
I've never seen it, actually, so I'll look out for that. We were talking about Titan's shadow earlier, but on the 27th, Titan itself enters Saturn's shadow at around 04:58 BST, so 03:58 UT. But that's under deep morning twilight conditions as seen from the UK. And when that happens, Titan will appear to disappear.
Yes.
As it passes into the shadow. But that will be in deep morning twilight.
And we've got another shadow event actually on the 31st where Ganymede's shadow can be seen transiting Jupiter's disk between 03:28 and 06:37 BST. And that's always a nice thing to look out for.
It is very, very striking.
Okay, well, we've wittered on, or you've wittered on, a lot about...
I didn't do any wittering. I was waiting for you to shut up so I could get a word in.
so we haven't left a lot of time talking about the night sky. But we can just talk about, very briefly, about the fact that the sky is quite bright at this time of year. So it's the brightest stars that tend to shine through. And, of course, you've got that massive asterism known as the Summer Triangle, made up of the stars Deneb, Vega and Altair, which are the primary stars of the constellations Cygnus, the swan, Lyra, the lyre, which is a musical instrument like a harp, and Aquila, the eagle, respectively. Cygnus is interesting, isn't it? Because the main pattern of Cygnus is known as the Northern Cross.
Yeah.
Okay. So you've got Deneb at the top, and you've got Albario at the bottom, which is that beautiful telescopic double star, warm yellow primary and a blue secondary. But the middle of the cross is marked by Sada, the star. Now, the two stars either side, which mark the swan's wing stubs, if you like, I've always known them as Gina, which is the one on the eastern side, and Rook, which is the one on the western side. But the International Astronomical Union, which is the only body that can actually name stars, has allocated different names. And I sometimes sort of fall foul of this. I don't keep up with, strangely, star names that much. And the Gina was now known as Aljana. And Rook, which was Delta Cygni, if I remember correctly, is now known as Phawaris. Now, it's been like that for a while, but it sometimes, if you've been into astronomy for a long time, you get used to names and things, and you just carry on using them, and suddenly you see these changes, and you think, oh, it's different.
Yeah, well, you've got to keep up the times, Pete. This is your trouble, you see. you could have gone to the meeting and voted to have kept it the same, I suspect, but no, there we go. I actually don't... What are their bear designations? Is one of them Delta and one of them Epsilon? I can't remember.
Yes, Phawaris is Delta and Aljana is Epsilon.
Yeah, I tend to... beyond the first two bright stars, I tend to know them all by the Greek letters. It's easier and easier to pronounce as well in many cases.
Yes, that's true. That's true.
If you have access to a telescope, we should point out that do take a look at Albario. It's a really beautiful double star. I think the current thinking is that they're not gravitationally connected. It's just line of sight.
Yes, that's correct.
I don't think we're 100% sure, but if they were connected, they would have an orbital period of many, many tens of thousands thousands of years. So I think
Yeah, that's the problem. There's not enough. We've not got enough observations of them to actually be able to work out whether they are in orbit. But I think that the latest research is pointing to the fact they're probably not.
No, I think that's true. Well, nearby, there in the constellation of Cygnus, still we have the North America nebula, which is just northeast of Deneb. It's actually it covers quite a large area of the sky if you look at it in photographs.
Yes, it does.
I have never seen it with the naked eye because the skies I live on are as dark. Have you seen it from where you live now, Pete? Out in rural Leicestershire, or have you struggled to find it?
No, I can't. I can't see where I am at the moment. But when I used to be near the sea, I have seen it from there.
Right.
And the naked eye is probably the best way to see it, to be honest.
Yeah.
Because it's so large, and it does have that sort of shape. Which makes it look like the continent of North America.
Yeah.
It's not the North American nebula because they don't own it, but it does look like North America. But it's a beautiful thing to photograph, and it's just part of that beautiful Milky Way that passes down the Northern Cross region, isn't it?
Yeah.
It passes down the northern. Well, if you go up, actually, it eventually heads over towards Cassiopeia. In fact, I think we'll end. So if you go from Albario through Deneb and you extend that line 2 times, you end up at Cassiopeia, which is the constellation which looks like a W. If you go from Albario to Deneb 1 times that distance, just to the south of where you end up there, you've got the core of Lacerta, the lizard. And in Lacerta, there's another W that looks like a miniature version of Cassiopeia.
Okay. I'm just wondering where you're going with this, but okay, that's to be fair, Pete, you can look at any.
That's probably the worst response ever. I thought.
Well, I'm trying to muster up part of me is thinking, what on earth are you going on about? And the other part of me is thinking, well, if you look at any star field, you can make out a W or an M out of it. It's hardly radical thinking,
yes, that's
is
not
it?
true.
It's really
no. It's actually known as the mini W.
Okay, so says Pete. I've never heard it, but maybe the IAU will officially name it the Mini W, and we can all go out and enjoy it.
Yes.
So short nights, but plenty to see. So thanks for joining us for this edition of the Virtual Planetarium. We'll be back next time. Thanks, Pete.
Thank you very much.